Alright, so welcome back to another video on Node.js. So what I'm going to do here is open the Zero to Mastery course, right? Go to the Node.js course here, in the socket section, okay, and talk about a theme. Look at this. So using the socket.io with Express, right? Which is something that I did yesterday, right? Okay. And so that to recap what I saw yesterday with using using socket.io with Express is because we want here is two things. Right now on multiplayer pong games, we just actually is open an index.html file, okay? But if it wants to serve that content statically at least, and one of the great benefits of using Socket.io is the ability to integrate with other popular web frameworks like Express, for example, right? So let's take a look at how can we use Socket.io alongside with the API with Express. So we build a barebone Express skeleton for our example here. Okay, so we install Express using npm, and then we define here the API counts Express, okay, and define some basic middlewares to serve content statically. So using is here. This is the first middleware that I set, and this is to indicate to the Express static what will be the directory folder structure where our index.html will be. Okay, so by using the path and using the join methods that join the path of the directory that the current file is in, with this we use the dir name node built-in, and we'll join the directory with the public folder, a folder that we create, right? And is here adding another middleware on the root route. We're going to serve this folder or this file, this index.html statically. Okay, so cool. So the only issue is that, okay, so not right now we set a basic Express app to serve static content, but this is not connected to our socket server. So what can we do, and how can we do that? Well, we move the socket.io implementation or socket code in their own file, socket.js file, and then since now our server files here require our socket code, okay, we import that code, socket code, into our server file, where here we're gonna call the listen function and pass the IO instance for that. So, but we don't have right now with this setup our Express server connected yet. So we need to pass the Express API or the Express API as a handler to our HTTP server, because Express, after all, is going to be handling incoming requests. And for that, we need to export the API ES file as a model, right? Something that I did here, okay? And now, once you import the API, inject that on the as a handler on our HTTP server, all right? And now, exactly, and now our server is now our socket.io and the Express server is side by side. So we're, yeah. So now our, so after we, so after I add the Express, after I add the API as a handler from our server, because after all, it will handle the incoming request. Okay. And then here is what I call the socket.io and inject the server here. So we add into our server is the IO, this web socket. Okay. Now we're running our Express app that serves static content, the pong game to the client, and socket.io side by side, right? And that's something very, very powerful and interesting to describe and to implement. So now I'm gonna look at how can we improve. Wait. No. Now I'm gonna look at how can we improve the readability of this code.
Welcome back. We'll need to pass Express as a handler, as a request listener, into our HTTP create server function, because Express will be handling requests coming into our server. So for that, let's import Express from our API file, which means that we'll need to export our Express server from this file. And it means that we won't be listening using Express's application listen function here. It's our top-level HTTP server over.
Mm-hmm. It's a top-level HTTP server.
Here, that is actually starting our server and listening for incoming requests. Express and socket.io are both just handling different types of requests, different types of data.
Mm-hmm. So Express and socket.io are handling different types of data
coming into our HTTP server. So now that we've
coming in to HTTP server,
exported our Express object here, in our server.js, we can require our API
mm-hmm.
and pass it into the create server function as a handler. So now if we run our server, we're running a server with both socket.io and Express running side by side. And now if we go to our browser and we point it to localhost at port 3000, we should see our Pong application being served at the root route. And going back to our server, we should see that a user connected and sent the player ready message. In fact, if we have two browsers open side by side in our testing setup, both pointed to localhost, you should see that we have a fully functional multiplayer Pong application. And because of socket.io's great integration with Express, on the client side, we can actually simplify our connection and remove IO's great integration with Express. On the client side, we can actually simplify our connection and remove the address of the server. Because by default, socket.io connects to the socket server at the same host, at the same address. So because our front-end code is hosted on localhost and our back-end code is also on localhost, socket.io knows what to do without us having to tell it explicitly. And if we wanted to clean up our imports in our server.js so that our external packages or external dependencies are at the top of the file,
Mm-hmm. Now for readability, we can organize our server code to look like this. The Visual Studio Code here.
We could do that by splitting these two calls up. So we would require HTTP at the top of the file, and then call http.createServer. Same thing for socket.io. We could do const io equals our import, and then do const socket server equals io of
Server.
our HTTP server here, which we can rename to HTTP server explicitly.
Exactly. So here is again we are is we improving the readability by making separate imports like HTTP, for example. Okay, like HTTP. So here is where we import that built-in model like this, and here we just only call the HTTP create server. The same for this, where we import is our IO socket IO server, and here we're going to call is this as the HTTP server, okay, and this as our socket server. And here it is to rename this as the server listener, but now in this case is the HTTP server listening, and um, the socket server.
And update when we pass it into IO, and also when we start listening on port 3000. Now, it might seem silly to be spending so much time on naming, but it's important.
Yeah. It might be silly because it's good. See, spending time. It might be silly spending time renaming things, but it is important. It is important.
There's a famous computer scientist called Phil Carlton who worked on one of
Okay. There is a famous computer scientist called Phil Carlton. Phil Carl Carlton. Phil Carl. Okay. Phil Carlton was working at Netscape. He taught an infamous phrase.
the first web browsers ever, Netscape. There's a famous computer scientist called Phil Carlton who worked on one of the
Mm-hmm. Who worked
first web browsers ever
for one of the first first web browser ever, Netscape. Netscape.
Netscape. who had a quote that went something like, naming is one of the hardest problems in computer science. When we have a lot of similar things being Carlton, who worked on one of the first web browsers ever, Netscape, who had a quote that went something like, naming is one of the hardest problems in computer science. When we have a lot of similar things being passed around, I personally find the best thing to do is to be as explicit as possible in how we name our variables. So you know what? Let's even call this API variable API server. So we know now that we're dealing with 3 types of objects that will
Exactly.
respond to requests. And
here we're going to rename this as the API server for these 3 objects here.
of course, let's not forget to use this socket server when we pass it into our custom listen function from sockets.js over here. All right. Now we can group our variables based on where they're used.
So don't forget here to pass is the proper socket server here. So we group based on how they use.
And I think that's a fair bit cleaner than it was before. Let's make sure our code still works. And if it does, there we have it. Now we can host our Pong Express server. So we know now that we're dealing with 3 types of objects that will respond to requests. It as possible in when we have a lot of similar things being passed around, I personally find the best thing to do is to be as explicit as possible.
Exactly. When we have several things
In when we have a lot of similar things
when we have a lot of similar things
being passed around, I personally find
pass around, I personally
the best thing to do is to be as explicit. When we have a lot of similar things being passed around, I personally find the best thing to do is to
I personally find that the best things to do is being explicit.
be as explicit as possible.
To do is to be explicit as possible
In how we name our variables. So
on how we name our variables.
So you know what? Let's even call this API variable API
That's what we call here
server. So we know now that we're dealing with 3 types of objects that will respond to requests.
exactly. So now here we have 3 types of objects that handle requests.
And of course, let's not forget to, we know now that we're dealing with 3 types of objects that will respond to requests.
Or that will respond to requests. That will respond to requests. Exactly.
And of course, let's not forget to use this socket server when we pass it into our custom listen function from sockets.js over here. All right. Now,
Git status. Git status. Okay. We add all of them. we need commit -m at express or integrate express to serve content statically. So we need push this change to the remote branch called main, and we got it.
Now we can group our variables based on where they're used, and I think that's a fair bit cleaner than it was before. Let's make sure our code.
And I think that's a bit more cleaner.
Now we can group our variables based on where they're used, and I think that's a fair bit cleaner than it was before.
Yeah, and I think that that's a bit more cleaner than it was before.
Let's make sure our code still works. And if it does, there we have it. Now we can host our Pong Express server anywhere on the internet, say on AWS.
Exactly. So now we can host our multiplayer Pong game anywhere on the internet.
And any two people with a browser can connect and play Pong with each other. How great is that? Welcome back. Two of the most common advanced features that we get from Socket.io are namespaces and rooms. Let's start by talking about our first advanced feature of namespaces, which we can see is a communication channel that allows you to split the logic of your application over a shared single connection. What does this mean? It means that namespaces allow you to separate the concerns of your Socket server over here by introducing new endpoints that the client can connect to for different tasks with different permission levels, or sometimes completely different applications. For example, say we had some tasks on our server that only administrators could perform. We could separate the server into an admin namespace and a namespace for normal users. Or if I had a game server and I wanted to host a multiplayer Pong application alongside a multiplayer Tetris application, for example, we could create a namespace for Pong and one for Tetris, and even one for, say, a chat or a lobby that allows us to connect with other players playing our games. And then our clients could choose which of our namespaces to communicate with. Namespaces allow you to separate one Socket server to be used for multiple purposes, using just one connection between the client and the server. It's up to you how to organize your namespaces. However, as a general starting point, I'd suggest keeping most applications, like a Pong application, to a single namespace. When we add more complexity and more applications, namespaces allow us to organize our server by the various tasks or applications that it's concerned with. So in our Socket server, if we don't explicitly create a namespace, Socket.io will use the default namespace, which we can see on the client side when we connect to our Socket server if we specify this first parameter when we connect. And we say that the / or the root endpoint, which represents the default namespace, is the one we're connecting to. Now I can start my server and load my Pong game, and it connects. Now if I wanted to add an explicit namespace for Pong, so that I could then create future namespaces for different games, or say a chat, I would specify the name of the namespace when I connect to Socket.io on the client side, and on the server side, I would create a new namespace by creating a variable for the namespace, say Pong namespace. And we would use this io.of function to pass in the name of the custom namespace that we want to create. So in our case, we decided on Pong. Now any of the functions that we call on the io scope on the IO object over here, we can narrow down to the Pong namespace. So in this case, if we replace IO with Pong namespace, we're saying that only on the connection to the Pong namespace do we respond to the ready event with a player ready message and starting the game. And when we emit, in this case, the broadcast to all connected clients, and we narrow it down to the Pong namespace, we're now broadcasting only to the clients that have connected to this namespace, like we did in our front-end code over here. And the rest of our actions here, on our socket, for example, now act on sockets for clients that have connected to our custom namespace. Now, if we built a Tetris game, in addition to our Pong game, we would then connect to our Tetris namespace instead of Pong, and we could create a corresponding set of event handlers by creating our Tetris namespace and calling the io.of function on the name of that namespace, so say Tetris. Now I could host multiple games on the same web server over here, and Socket.io would be smart enough to share a single pipe or a single shared connection when talking to the different namespaces, while still giving us that separation of concerns that we need when building large-scale systems. All right, let's talk about rooms in the next video. I'll see you then. Waiting for a game to start and for another player to join. And we could communicate. Let's look at the most important advanced feature that we get from Socket.io, which is rooms. Say we wanted to create a Pong server that supports many users joining and having multiple multiplayer Pong games running at the same time. We could create game lobbies, which players can connect to while they're waiting for a game to start and for another player to join. And we could communicate with the other players in those lobbies, and when ready, start our game of Pong. This is all possible with these core features of Socket.io, such as namespaces and rooms, that are not available with the native WebSocket functionality. So what are rooms? Rooms are a way of further dividing Socket.io namespaces, which we saw previously, into groupings of sockets. Instead of dividing our socket server by separating functionality by endpoint, for example with our Pong endpoint, we instead divide our socket server by groups of clients or sockets that are connected to it. And these groupings only exist on the server. The client knows nothing about them. In fact, by default, each socket over here gets its own room. So if we don't explicitly join a room on the server, each socket is separate, and this grouping of clients by room has no meaning. But say we wanted to introduce these groupings of clients, and we wanted each pair of players that's ready to start the game to have their own room to play a game of Pong. We would want the players to join a room when they let us know that they're ready to start and that they've loaded the Pong game, which is when we receive this ready event. And the way we join a room in Socket.io is to call this join function on our socket object. And we pass in the name of the room that we want to join. So how are we going to name our rooms? How do we know which player should join which room? Well, we can create a variable called room, and we'll say each room's name starts with the word room, followed by the number of the room, which we want to be the ready player count divided by 2, because each pair of players is going to have one room. But we want this to be integer division. We want 1 divided by 2 to be 0, and not 0.5, so that the first player who's ready, when the ready player count is 0, joins room 0 divided by 2, so 0, and then the second player who's ready, which will be when the ready player count is 1, will join room 1 divided by 2 in integer division without that decimal spot, which we'll do with this math.floor function. So now, when the ready player count is 1 for the second player who's joining, prior to the count being increased, that player will join room 1 divided by 2, 0.5, and then floored, so remove the decimal points, and it will join room 0, just like the first player. So using this strategy, we can group players into pairs, where each room holds a pair of players. And we can leave our rooms when our client disconnects, and we receive the disconnect message. And the way we leave a room is similarly socket.leave, passing in the name of the room. We want to do this so our rooms don't stick around forever. But Socket.io already removes us from a room when we disconnect by default. So we're just doing this here to be explicit. Okay, but wait, we don't have access to this room variable in this scope over here. It's declared only when we're ready. So let's move this room variable and keep it around for the scope of the entire connection. And we can log the room that the player joins when they ready up. Now we want to update our broadcast messages. Rather than broadcasting to the entire namespace for our Pong game, we want to broadcast just to all the clients in our room. If we go back to our handy emit cheat sheet and we scroll down here, we can see that to send to all clients in our room, including the sender, we want to use this in function of the IO object. And in fact, all of the functions that the IO object has apply to each individual namespace. So we'll want to call emit on our Pong namespace, calling the in function on our room. So we'll do Pong namespace dot in room dot emit start game. This will broadcast to all the clients that have connected to this room. And we'll want to do something similar for our paddle and ball movement broadcasts. Rather than calling the socket.broadcast.emit function to emit to all the clients without specifying a room, we'll call the socket.to function and emit on that room. This is how we send to all the clients in the game room, except for the sender. So we're doing the same as before, but narrowing our message to that specific room.
To that room.
So we'll replace broadcast with to, and then the name of the room. Similarly for the ball move event. Just like that, our server now supports multiple rooms with multiple games of Pong happening side by side. If we wanted to test this, we could start our server back up and on our client side, join our first room. So we have our first client ready, our second client should become ready, and the room begins the game. Let's get a few points on the board. All right, so this game is going. Now if I refresh both clients, I should join a new room. And if I go back to the server, I can see that, first of all, our socket IDs are prefixed by the name of our namespace. And when I refreshed, the two clients, or the two tabs that I refreshed, disconnected from the game, and then subsequently reconnected. The first time they joined room 0, and the second time they joined room 1. Looks like everything is working, but let's see if we can get two games going side by side. So here's our first game that's currently active, and now in a different pair of browsers, let's join a third room. And now we have another game of Pong that's happening side by side with the first game that we started. And this could be extended to as many games of Pong across the internet as we wanted. Rooms have allowed our server to scale to as many games as we wanted. They model real-world applications, like chat rooms and game lobbies, very well. And unlike namespaces, rooms can be introduced, joined, and disconnected from in real time. Very, very good stuff. Okay, I'll see you next time.
Okay.
Hey there. I wanted to take a second at the end of it all, at the end of your learning journey, to just say this one thing, and that is, thank you. I know your time is valuable. We have limited time on this earth, and you decided to spend your time and your money, frankly, with us, doing something that takes a long time to learn. So truly, from the bottom of our hearts, I know it sounds cheesy, but thank you for dedicating your time and effort to this course. I hope you got what you wanted out of it, and congratulate yourself for getting this far, because a lot of people start, a lot of people have hopes of learning, but they give up along the way. But you didn't do that. You worked through the challenges, the problems, and you got here. Now, your learning journey doesn't end here. It keeps going. But I hope this created a foundation for you to go off and learn things on your own, get a promotion, get hired, start a new business. Whatever it may be, again, thank you and best of luck with your learning journey. This is just the beginning of whatever you decide to do in the future. So thank you and good luck.
And thank you, my friend. Okay. So that'll be all for this video. Take care.